Okay friends, here we go. We're gonna get started with our Bellringer for Thursday, and we're gonna start with the line plot because I think these are the hardest of the problems, and it's always a good idea to start with the more challenging problems first while your brain is fresh. So I usually like to start by rewriting each fraction because when the fraction bar is horizontal like this, that may be not the way you're used to seeing fractions. Now notice some of these fractions are improper fractions, meaning they're greater than 1 whole. Like 6/3 is definitely greater than 1 whole. So the first thing we need to do is find our largest value and our smallest value. So 4/4, that's equivalent to 1 whole. And then 6/3, I know that's greater than 1 whole. If I show two groups of 3/3, here's 1/3, 2/3, 3/3, 4/3, 5/3, and 6/3. So 6/3 is the same as 3/3 plus 3/3, which is the same as 2 wholes. So I've got 1 whole to put on my line plot, 2 wholes to put on there, and then I also have 1/2, and then 3/4. Now I really love it when we have halves and fourths because those are easy to put into equivalent fractions. 1/2 is equivalent to 2/4. And I can show that with an area model. Here's 1/2, right? 1 out of 2 pieces. And then if I cut that in half, that's multiplying my numerator and my denominator by 2. And now instead of 1 out of 2, I have 1, 2 out of 4 shaded pieces. So 2/4. Okay? So the values I need to put on my line plot are 1/2. Oh, no, sorry. 2/4. There's 2/4. 3/4. 1 whole. And 2 wholes. Okay. Got it. 0, 1, 2. 1/4, 2/4, 3/4, 1 whole, 1 and 1/4, 1 and 2/4, 1 and 3/4, and then 2. Okay, so 2/4, 3/4, 1 whole, 2 wholes. Okay, next we're going to work on our subtraction problem, 9 and 4/7 minus 1 and 3/5. So we're going to start by finding the least common multiple for 7ths and 5ths, and that will help us find a common denominator. So I'm going to skip count by 7 and by 5s. Actually, I don't even really need to skip count because I just know with 5s I'm not going to have a common denominator or a common multiple until I get to 35. So this is one of those cases where you could just multiply your numerator and your denominator together to get your common denominator. So our whole numbers can just stay put. We don't need to worry about those. And I'm going to multiply my numerator and my denominator. Whoops. I'm going to multiply my numerator and my denominator by 5 in order to convert 4/7 to 20 out of 35. And then I'm going to multiply my numerator and my denominator by 7 for this other fraction to convert 3/5 to 21 out of 35. And then I'm ready to subtract. Okay, now I'm going to show you guys how to do this using an area model. Not because it's the most efficient way to solve this problem, but because I want you to have an understanding of what I'm doing, and because I'm subtracting 20 out of 35, I'm subtracting 21 from 35 from this. It's kind of hard to show that, like, you don't borrow the way you would normally borrow with fractions. So I'm going to show you with an area model. Okay, so here's my first area model, and I have it divided into 35 equal pieces. I've got 7 groups of 5. So 5, 10, 15, 20, 25, 30, 35. And for my 9 wholes, I can just duplicate this and say the whole thing is shaded in. And of course that represents 1 whole. Or 35 out of 35. Okay, so now, like I said, this is not the most efficient way to solve this, but I think it's important to have a visual. So here we have 1 whole, 2 wholes, 3 wholes, 4 wholes, 5 wholes, 6 wholes, 7, 8, 9, and then I need to shade in 20 out of 35 to represent this portion here. Five, 10, 15, 20. 5, 10, 15, 20 out of 35. 25, 30, 35. Okay. So now I have represented, shaded in blue, 9 wholes, and then most of a tenth. 20 out of 35 pieces of my tenths. Now from that, I'm going to subtract this portion. So I'm going to take away 1 whole. That's easy enough to do. I can just cross that out. Let me do it in red. Cross it out. Bye-bye. So how many wholes does that leave me with? 1, 2, 3, 4, 5, 6, 7, 8, and part of a 9th. So I have 8 wholes, but now I need to also subtract 21 out of 35. Now, this is where the question of, like, how do you borrow with fractions, right? Because I'm going to cross out, here's 5 out of 35, 10 out of 35, 15 out of 35, 20 out of 35, and 21 out of 35. See that tiny little square that I crossed out down at the bottom? Cross that out down. Okay, so that leaves me with, this is gone. I've crossed out this whole portion. That's totally gone. And that leaves me with most of this model here, except for that one little piece that I crossed out. So 34 out of 35 of this is left and needs to be included in my difference. And that leaves us with how many wholes? 1 whole, 2 wholes, 3 wholes, 4 wholes, 5 wholes, 6 wholes, 7 wholes, and most of this 8th whole. 34 out of 35 pieces. Okay, I'm just going to subject you to one last problem, which is we need to find an equivalent fraction for 4 out of 13. So I'm going to divide this whole into 13 equal pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I think that's 13. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, and then I'm going to shade 4 of them. So that's 4 out of 13. Now for me, the easiest way to come up with an equivalent fraction is just to take, let me make another copy of this just in case I want to do more than one. Put this down here. Okay. So I'm just going to take each of these pieces and divide it in half, which is the same as taking 4 out of 13 and multiply it times 2. I haven't changed the size of my whole. Like if I imagine that this whole is a pan of brownies, I still have the same total amount of brownies, but I just am changing the way I'm slicing up that pan of brownies. And so now I have 8 out of 26 pieces. Now, I could do it differently. I mean, it just says come up with an equivalent fraction. It doesn't give you any specific rules about how to divide up that, you know, if we're imagining it's a pan of brownies. So I could take my 4 out of 13 and slice up my brownies so that each 13th has now been cut into 3 equal pieces. 1, 2, 3. And that would give me a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 12 shaded pieces out of 39. So these are both equivalent fractions.